Before you begin Section 3, please make sure you have taken the Elluminate quiz for Section 2. This is the final section of your notes. In this section, we will look at opposites and modeling multiplication with negative integers on the number line. I'm going to start by reviewing opposites. Opposites are two numbers that are an equal distance from 0 on the number line. So for example, if I start at 0 and I go to the left 5 units, 1, 2, 3, 4, 5, I find negative 5. And if I start at 0 and go to the right, the same number of spaces, 5, 1, 2, 3, 4, 5, I have the number positive 5. So since 5 and negative 5 are the same distance from 0 on a number line, they are considered opposites. And they are on opposite sides as well. And that's the idea we're going to be using to model multiplication with negative integers on the number line. So let's begin with an example. I have here 5 times negative 3, and we know that the answer will be negative 15, but why is it negative 15? What makes that work? Is it just a rule? It's not just a rule. There is a reason why a positive times a negative number equals a negative number all the time. And it goes back to the idea of repeated addition. Remember, 5 times negative 3 is saying that I have 5 groups of negative 3. That means negative 3 plus negative 3 plus negative 3 plus negative 3 plus negative 3. And we know from our recent study that when you add negative numbers, you get a larger negative number. So let's show this on the number line. As in the previous video, when you have 5 groups of negative 3, that means that each of the 5 groups contains negative 3, right? And so we want to use the spacing 3 to set up our number line. So each group has 3 in it, so we're going to count by 3s on the number line. So you set up your number line, 3, 9, 6, and so on, negative 3, negative 6, negative 9. And then we're going to model this. But instead of going to the right, we don't have groups of positive 3, we have groups of negative 3. So we are going to go to the left. So my first group of negative 3 goes here to the left. And then I continue to travel to the left because I have a total of 5 groups of negative 3. So we are always going in the negative direction on the number line. And we end at negative 15. So to review, you still start at 0, but in this case, we're going to move 5 groups of negative 3, which means we go to the left, and we end at negative 15. Now let's tackle the most abstract idea of multiplying negative and positive integers. When you have a negative times a negative number, you've probably been taught that the answer is positive. Why is that true? When I add negatives, it stays negative. So when I multiply negatives, why does it turn around and suddenly become positive? It has to do with direction on the number line, and again, going back to the idea of opposites. So when I have 2 negatives, like in this example here, negative 5 times negative 3, this symbol right here we think of as negative, but this symbol right here, we're going to treat it as the word opposite. So here we're saying the opposite of 5 groups of negative 3. In other words, we're going to change the direction we travel on the number line. Instead of going to the left, even though we have negatives, we're going to go to the right in the opposite direction. So what we're saying here is that the opposite of 5 groups of negative 3. Again, each group has negative 3 in it, so we're going to set our number line up by 3's. And we're going to turn everything around in the opposite direction. So remember, 5 groups of negative 3 is negative 15. But if I go to the opposite would be starting at 0 and going to the right. So I end at the opposite of negative 15. I still go in my groups of 3, but I go in the opposite direction. 3, 6, 9, 12, 15. So when you have that negative 5, it's really saying the opposite of 5 groups of negative 3. So instead of negative 15, the answer is positive 15. If that's a little tough to swallow, we're going to do another example right now. But let's just review. Remember, you start at 0, and then you move the opposite direction of 5 groups of negative 3. And let's change that so it's spelled right. Opposite, there we go. Groups of negative 3. And you end at positive 15. Here's another example where we're multiplying 2 negative numbers. Remember, the negative in front we consider as the opposite. So we're saying the opposite of 7 groups of negative 12. So we have 7 groups, and in each group is 12 negatives. So it's the opposite of 7 groups of negative 12. Since each of the 7 groups has negative 12 in it, I'm going to set my number line up by spacing by 12s. Like so. And then remember, I'm going to go in the opposite of the negative direction. 7 groups of negative 12 would look like this. We'd go to the negative side. But since we're doing the opposite of a negative, we go to the right. And here's my 7 groups of negative 12 in the opposite direction. The opposite of 7 groups of negative 12 is positive 84. So you start at 0, you move the opposite of 7 groups of negative 12, and you end at 84. Last of all, I want to talk about if you have a negative and a positive, but the negative is in front. Do we still treat it as the opposite? Sure, you can do it that way. You can say the opposite of 8 groups of 4 is negative 32. You can also rewrite this to treat it the same way we did the first example. So here, remember, we can write negative 8 times 4 as 4 times negative 8. And that goes back to section 1. Remember, the reason we can do that they have the same answer, is because of the property of the commutative property of multiplication. It says that it doesn't matter what order I multiply in, I'm still going to get the same answer. That's why either way, a negative times a positive is a negative. It doesn't matter if the negative comes first or second. So here, remember, now we have, in the switched around version, we have 4 groups of negative 8. And so since each group contains negative 8, I'm going to set up my number line to skip by 8s. And then, since it is there is only one negative, and it's 4 groups of negative 8, I take those 4 groups of negative 8 and I go to the left. So here's 1 group of negative 8, and 2 groups of negative 8, and 3 groups of negative 8, and 4 groups of negative 8. So remember, we started at 0, we moved 4 groups of negative 8 to the left, and we end at negative 32. So even though the rules for multiplying integers can sometimes be a little confusing, I hope this helps to clarify why. Even when it's abstract, there is a reason for it. It's not just a made-up rule. It's something that has a reason that we can show on the number line. At this point, you have two things left to do for task 16. You need to go back to the Google Classroom document and click on the link where you will take your Check for Understanding number 3 and put your score on your document. Then you need to write a summary of the notes. You can choose to write a summary of all 3 sections, or you can just write a summary of section 3. But what you do need to include is an explanation of big ideas and definitions, and give step-by-step explanations for at least one example. The summary must be at least 6 sentences.